right, guys, welcome back to our second part of 5.2, and we're just going to hop straight into it. There are three more trig ratios, which are called cosecant, secant, and cotangent. These are the reciprocals of sine, cosine, and tangent, respectively. And whenever we say respectively in math, we just mean that since I said cosecant first here, and I said sine first here, those are the two that go together. And same thing with cosine and secant and cotangent and tangent. So the words are cosecant, which we already have up there, secant, and cotangent. And then the symbols for when you're writing out math problems is going to be cosecant, and then we can put theta, and then secant of theta, and then tangent of theta. And then the definition, they are reciprocals, right? So these, I'm just going to put equal signs here. They're going to be, cosecant goes with sine, so it's 1 over sine of theta. Or we can kind of think about our SOHCAHTOA, except it's the reciprocal, so we're going to reverse it, right? So sine of theta is so opposite over hypotenuse. So the cosecant, we're going to flip them, and it's going to be the hypotenuse over the opposite. And we're going to keep doing this. Secant is the reciprocal of cosine, so 1 over cosine. And cosine is normally adjacent over hypotenuse, so it's going to be hypotenuse over adjacent. And then tangent of theta, or cotangent of theta, is the reciprocal of tangent, so 1 over tangent of theta. And that is normally opposite over adjacent, so this time it's going to be adjacent over opposite. And again, when we're doing these, it's all in reference to an angle theta here, right? If that's theta, this is going to be the opposite side. This is going to be the adjacent side. And this is going to be the hypotenuse. So an example, if cosine theta equals 3/4, find secant of theta. Well, we know that secant of theta is 1 over cosine of theta. And we know cosine of theta is 3/4. So let's just plug that in. Secant of theta equals 1 divided by 3 divided by 3/4. And when we are dividing by a fraction, we actually multiply by the reciprocal. So that's the same thing as doing 1 times 4/3. 1 times anything is itself. So we have secant of theta equals 4/3. Now down here we have if cosecant equals 1.345, find the sine of theta. So we know that sine theta equals, or we should write this. We know the cosecant of theta equals 1 over the sine of theta. And we know what this is, right? So we can plug that in once my screen comes back on. It turns off every now and then. Hello. Okay, 1.345 equals 1 over sine theta. And then we would multiply the sine over and divide the 1.345 over. So we would get sine of theta equals 1 divided by 1.345. And if you type that into a calculator, you should get 0.7435. 0.74. So there are our two answers for that one. Now, example 4, find the values of the 6 trig functions for angle P. So again, we're going to need this hypotenuse. So we would just do the length of the hypotenuse is going to be 10 squared plus 7 squared, which is 10 squared is 100, 7 squared is 49, so the square root of 149. And that will simplify to, where are we at? I guess that probably just gets left like that. Yep. So that doesn't simplify at all. But now we can write this over here and it'll be really easy. Square root of 149. Right. And we're talking about angle P. So I'm just going to mark angle P so I know which one we're talking about, and then it all becomes super easy. So we're going to have sine of P, cosine of P, tangent of P, and then we're going to have all the reciprocals, which is going to be, remember, cosecant goes with sine. I know it's a little weird because you have cosine and then cosecant. You think those might go together, but it's sine and cosecant. And then we have secant. And then we have cotangent. All right, so sine. Let's remember SOHCAHTOA. Sine opposite over hypotenuse. Opposite from P is 7. And then the hypotenuse is square root of 149. And then typically you would want to rationalize. So we would multiply the top and bottom by the square root of 149, which would get us 7 times the square root of 149. And then the square root of 149 would cancel on the bottom. And then cosine of P is going to be adjacent, which is 10 over hypotenuse. 10 over the square root of 149. And again, we would rationalize and get 10 square roots of 149 all over 149. And then tangent is going to be opposite, so 7 over adjacent, which is 10. And then for these, remember, line here, now we can just flip these other ones, right? So cosecant is just a reciprocal, or we can just flip. So sine, we already have, we can just flip this 7 and square root of 149. So 149, 7. Same thing here, we can just flip them. So it'll be the square root of 149 all over 10, that is secant. And then the tangent is just going to be 10 sevenths. And those ones are pretty simple. All right, so real quick, let's look at a 30, 60, 90 triangle. And I'm just wondering if we can generalize these trig ratios for this kind of triangle or these side lengths. So here I have an equilateral triangle. So these are all 60 degrees. So I'm going to write 60 degrees. And then I'm going to draw a line right down the middle here to create a altitude, which is a right angle. And then this would have to be 30 degrees, right? So I've created a 30, 60, 90 from an equilateral triangle. And since this was an equilateral triangle, all these sides would have been the same, right? We can say that's x, and then if this whole side was x, that means this length right here is x over 2, right? And now let's find the length of this side right here, the middle one. We would do the Pythagorean theorem, which would give us, we'd want to take x squared, the square root of x squared, since that's hypotenuse squared, and then minus x over 2 squared, right? And what's that going to get us? That's going to get us the square root of x squared minus x squared over 4. Well, x squared is the same thing as 4x squared, right? 4x squared all over 4. This should be this whole thing. Minus x squared over 4. And so then we get the square root of 3x squared. 4 of something minus 1 of something is going to be 1 of that something, and then all over 4. And then the x squared can come out as an x. And then square root of 3 stays, and then that square root of 4 on the bottom can come out as a 2. So this side length is x times square root of 3 over 2. And right, and here I'm gonna redraw my 30, 60, 90. So there's my 30, 60, 90. I'm kind of just ignoring this triangle. And I've just rewrote this one over here. I know it looks a little different. But notice all these side lengths, I can multiply these all by 2 to make it a little easier. So I know the hypotenuse, if I multiply by 2, that's going to be 2x. And the side across from 30 degrees is going to be x over 2, which when I multiply by 2 is going to be x. And when I go across from 60, if I multiply by 2, those 2's are going to cancel out, and I'm going to be left with x squared root of 3. And all I did was multiply everything by 2 to make it look nicer, right? So I've just rewrote that triangle on the left, and then since everything's proportional, I just multiplied everything by 2 to make it look nicer. And what does this mean? This means that for any 30, 60, 90 triangle, we now know the side length. So if we knew that this side length across from the 30 degrees was 5, that would mean the hypotenuse would be 10, right? 2 times 5. And then this would be, if x is 5, then this side would be 5 squared root of 3. And so that helps us learn the sides of it, 30, 60, 90 really fast. But that has other implications. So since we have this x, 2x, and x squared root of 3, we can do the same thing to 45, 45, 90. And so notice here we're rewriting, we have the x, 2x, and x squared root of 3. And we could do that a similar thing with a 45, 45, 90, where we would get y, and y squared root of 2. And this leads to a table that you can do very easily. So you should definitely take note both of these 2 triangles here. I would write these down, and I would write this table down, and I would start to memorize this table. So just as an example, we'll notice that let's look at sine of 30, right? If we look at sine of 30, and we come up here, so 30 degrees is here. So if we look for sine is opposite, which is x, over hypotenuse, right? Which is 2x, right? There's an invisible 1 in front of that x. The x's are going to cancel out. So sine of 30 is always going to be 1/2, right? And you can do that for anything. Just for one other quick example, let's do tangent of 60 degrees. So tangent of 60 degrees, we should get square root of 3. So tangent of 60 degrees is going to be, so we're looking at this angle now, tangent is going to be opposite. So x squared root of 3 over adjacent, which is right next to it, which is x, the x's cancel, and we're left with just the square root of 3, right? So that one checks out. And it doesn't matter the size of the triangle because these are ratios, right? If this is 100, this is always going to be 100. If this x is 100, this is always going to be 100 square root of 3, and these 100s will just cancel, right? So this is true no matter your triangle, and these are just general ones. And you do the same thing for these, for the 45 degrees ones. And you can do that for the other ones too. So let's just do one that might be a little bit more tricky, like secant of theta. Let's do secant of 30. So I know secant of, I know cosine and secant go together, right? So secant, and then I can figure out that cosine of 30 is square root 3 over 2. So I know cosine of theta is square root 3 over 2. And then I know secant of theta is just the reciprocal, so I'm just going to flip those, right? So secant of theta, and I'm just going to flip them 2 over the square root of 3. And then once I do that, I just need to rationalize. So I'm going to multiply the top and the bottom by the square root of 3, um, which is going to give me 2 square roots of 3 all over 3. And so that's how we get that value. But again, I would pause, without this writing on there, and I would both take note of this table and these triangles because these are very common values that you will have to get accustomed to. And especially, if you get to college or take higher level math classes, eventually you want to get to the point where if I say, what's sine of 30, you just want to spit out a half, like right away. If you can't, it's okay. We could use calculators for now, and you can always use these triangles to find them, but it might also be nice just to get comfortable using these. And so that is going to wrap up 5.2. If you have any questions, as always, email me, save them for class, save them for our Zoom meeting, and have a good day, guys.